Hi, so my name is Jacqueline Amezcua, and the topic that I chose for my Power Systems with Renewable Energy project was wind turbines. So, basically the concept of renewable energy. So, what is that? So, well, at least in my opinion, I think what it is I've always been interested in the whole process of recycling and reusing. Ever since I was little, I remember that Um, we watched like this recycling video with like cans and all that stuff, and I don't know, like it like played like a major role in like my life. I don't know why. Like I can think of like that specific memory. But it was like a little documentary about it, like it's recycle, reuse, reduce. I don't know. It just always stuck with me. And then honestly, I really took this course because of the interest of renewable energy. I don't know, it's like an interesting topic. And then, honestly, the whole concept of working through natural resources and using that energy to power something up. And then, like, yeah, that's kind of like one of the many reasons why I chose engineering within itself. And honestly, just the curiosity of how the world can run, like, without the things that we have, like, such as like solar panels, um, fossil fuels, wind turbines. So like the variety of things that we can use is honestly really crazy, in my opinion. And so so why wind turbines? Like I mentioned, simply curiosity, and also how I briefly mentioned that I've always been intrigued with the idea of like renewable energy. And so yeah, and it seemed like it was like the topic that I knew the least about. And then also I didn't go the solar way because I'm already doing a senior project on that with my three other group members. So I wanted to choose something different. Okay, so what is wind energy? So wind energy is basically like the process by which wind is being used to generate mechanical power or electricity. So that's like the basic gist of it. Okay, so what is the purpose of a wind turbine? So as you can see in the picture, it's like the diagram of a wind turbine, and then it leads to the transformer, and then it produces energy for the consumer. So but that's like way basic. So other one of the purposes that it has is to convert kinetic energy in the wind into mechanical power. So yeah, within itself, it's converting kinetic energy into mechanical power. So, and then another purpose that it does is that leads that mechanical power can be used for specific tasks such as like grinding, um, pumping water, producing electricity. Like in the third, like I have in the third one, it says can be converted into electricity by a generator. So yeah, that's kind of the gist of a wind turbine and what it does. Okay. From what I've learned is that the first ever wind turbine was discovered, or not necessarily discovered, but built in 1897, and it was in Scotland. And the professor James Blythe of Anderson College is the one who created it. And apparently it was only 10 meters high. As you can see in that picture, that's the diagram. Well, not a diagram, that's the photograph of it. And so it was a cloth-sailed wind turbine, which was used to charge accumulators developed by the Frenchman Camille Alphonse Vallier. I wasn't sure how to say that. And then, yeah, to power the lighting of the cottage. And it was said to be the first house to be lit by like renewable energy of like a wind turbine. And so he had also offered the surplus of the electricity to the people of Scotland, but during that time, I guess like people thought it was like the devil's work to accept um, energy in that way. I guess just because they didn't understand it, they didn't want it. So yeah, that was I thought that was like a little interesting fact to throw in there. Okay, so the structure. Okay, so the this is okay. What I was talking about before was the old structure, the first new one, and then now I'm gonna be going into more like the newer and latest models. Not necessarily specifics, but just to get like the drive, not drive, but like purpose of it. Okay, so the for the structure, as you can see on the diagram on the left, it has the support structure and then the substructure and then the foundation, which entails with like the tower and then the top structure, which what I have more in depth on the right side, is the nasal. I'm not sure how to say it, but nasal, is it nasal? No. Um, but yeah, so that's basically where like the actual it's considered the drivetrain, and it's made up of the router, the main bearing, and the main shaft, the gearbox, and the generator. And basically what that does is converts the low speed and the high torque rotation of the turbine's motors, for this instance, which is the blades and the hub, into electricity. So yeah, that's basically what it does. And then, oh, also one fun fact that I like threw into here from my research was that wind turbines are so complex compared to the basic ones that were made out of cloth, obviously in wood and for the main foundation, but um, they're way simpler diagrams and design. But the structures nowadays are made up of about 8,000 components too. So I thought that was like a crazy thing. But yeah, so we're gonna move on to how a power plant works. So basically, it produces electricity by having an array of wind turbines in the same location. So as you can see in the picture, that's one of the power plants. Um, so basically, like it's just a whole bunch of wind turbines just scattered, but in specific locations to produce electricity. So it's like a power plant. You can call it a power plant. You can call it a farm. There's different terminologies for it. So, like I mentioned, the location of the power plant um, matters because many factors play into it. So it'd be like the wind conditions, um, location, and like climate based off of like what country, like not everywhere has the same amount of like wind per se. And the surrounding terrain, access to electric transmission because if it's too far, they can't get it to like database or like a grid for it to be transferable. At least we're not to it not I don't want to say it. We're not we don't have that type of technology yet. It's in the works actually what I read. But we can't have it too far off of like civilization because it can be transferred. So yeah. And then each turbine generates electricity, which runs to a substation where then it transfers to the grid where it powers our communities. So, like, that's basically what I was saying about how that's the process of it. But one downside of it is that it can be too far from civilization, or else that electricity cannot be transferable in long distance. Okay, so some advantages that I found. were, of course, that wind power is clean and renewable energy source. So basically, what this whole project is about is how, um, well, I feel like most renewable energies are already clean, but some have their downside. But this one, specifically, it provides electricity without burning any fuel or polluting air, which is good with considering our the talk about like climate change and everything, and so that's definitely a plus. Another advantage that I came across was that wind power creates good paying jobs. So from what I read was that over 120,000 people in the US are working in the wind industry. And so, and yeah, and the number just continues to grow. Like, I didn't realize how many jobs were created by that, but it makes sense. So it's wind power is only getting bigger, or like wind turbine energy is only getting greater, is what I should have said. And so I would hope it continues to create more jobs. And so another advantage was that wind power is cost effective. So wind turbines provide one of the low priced energy sources. So it's one of the cheaper options when it comes to renewable energy, based off of like materials, maintenance, and just keeping it up to date, like with damages or anything with like natural disasters or and I don't think it would probably be in those type of situations when it comes to like natural disasters, but anything could happen. So yeah. And the next advantage that I found was that it worked in different settings based off of different agricultural settings. Like it can be in different countries, different states where there's more terrain. It could be more dry, but there's wind, or when it's rainy and it still can work in those situations, is what I was getting at. And then another advantage is that wind power is a domestic resource that enables the U.S. economic growth. This was something that I found very interesting because I genuinely, well, coming into this project, I didn't know much about this topic, but this honestly, like, was pretty intriguing. From what I read, is that it generated more than 9% of the net total of the country's energy. So 9%, that's a lot considering it's not new, but it's not too major in the scale of what it could possibly be. And then so also because of that, investments in new wind projects added 20 billion in the US economy. So that's insane numbers, honestly. So that was very all interesting for me. Okay, but with advantages, there are some challenges in this. So, okay, first being wind power must compete with other low-cost energy sources. So, although it may not be like completely the lowest, but it's still like in the range of with like solar. Um, so one downside could be like for some countries or some states, it's not convenient for them to have windmills because they don't get that much wind in their locations. So then it's not cost effective for them. So that's what I meant by that. Okay, another challenge would be ideal sites are often in remote locations. So like I had mentioned before, there's like challenges in where to specifically put them because you can't put them too far away from civilization because it can't transfer that energy. So that was one of the challenges when it comes to wind power. And then also turbines produce noise and alter visual aesthetics. So they're not the most aesthetically pleasing things to see. when it comes to like, let's see, urbanized areas, like you don't want to see like a whole bunch of windmills. And since they're noisy, you don't want to be hearing that. So that's definitely a downside to it. But I think even within that, I think it could be, there can be a compromise within that. And then, so wind plants can impact local wildlife. So although there wasn't much that I read about like it actually affecting the wildlife, it's still an issue because it is in their terrain, and so it could cause some problems within that in the long run. Okay, something also that I found pretty interesting. I didn't realize that there were so many different wind turbines. So it could be like the residential scale on-site energy use, which is literally less than 10 kilowatts. I say literally like if it's a little bit, because yeah. Anyways, those specifically do not produce as much energy as like the bigger scale ones. This is probably like the smaller scale ones, which only would produce energy for a home. And so the next one would be a small commercial scale on-site energy use, which is from 10 to 50 kilowatts. And from here, it would only produce more than the average house consumes, but can be well suited for small businesses, farms, like semi bigger locations, and like schools, office buildings, the campuses, anything like that. So then the one ahead, like after that, is the 50 to 250 kilowatts, which is the commercial on-site energy use. And so that, for example, that would like power up larger facilities like factories or yeah, and communities. So it's definitely bigger scale. And so the next one would be from 500 kilowatts to 1.5 megawatts. And that is for the category of large commercial or industrial energy use. So these are definitely like upsized a lot, and they are well suited for large on-site industrial loads, like small wind farms. And so yeah, the biggest would be for energy use. The biggest for energy use is 1.5 to 7.5 megawatts, which is for the utility scale, and they power up and generate cost competitive electricity at power plant scales. So yeah, I didn't once I read that there were so many different ones and they're categorized as, I mean, by kilowatts and all, it's definitely a lot. And so I just wanted to preface the difference between a kilowatt and a megawatt. So a kilowatt is 1,000 watts, and then a megawatt is 1,000 kilowatts, which makes it 1,000,000 watts. So I thought that was well. I mean, anything else energy. I mean, I know the energy units, but I just wanted to touch on that a little bit. Okay, so how much do wind turbines truly power up? From what I've learned is that they power up nearly 70,000 wind turbines across the country are generating clean and reliable power, which leads to wind power capacity totals nearly to 140 gigawatts, which is 1 billion watts. And so it made us categorized as the fourth source of electricity generation capacity in the country. And this was in 2021. And so basically, that's enough to wind power to serve the equivalent of 43 million American homes, which is baffling, but it's insane to say the least. And so some fun facts that I like wanted to just throw in were that how massive they are. Like you can see in the diagram, but like compared to like big structures that we know how big they are, and like so it gives us a like image of like how big they truly are. Yeah, so like a wind turbine blade can average up to 200 feet long, and the towers within themselves are an average of 300 feet tall. So that's yeah, that's insane. And so one thing I found interesting with that comes with height, obviously it's for a reason that they're that tall, is that the taller it is, the more wind there is. I didn't realize how far up wind still like goes. Like I don't know, I guess it was just wasn't a thought in my mind. And so yeah, it was crazy. And then another fun fact that I saw was that the United States wind power capacity was about 136,000 megawatts at the end of 2021, making it the largest renewable energy source in the United States. I genuinely didn't realize that so many, well, after this project, I did know that. But before this project, I didn't realize that wind turbines were used that often. Like, I thought the world was running mostly, obviously, on fossil fuels, but I thought like solar power, I generally thought solar power was way up there more than um, wind power. So it was definitely something different. And so also the speed. I was like, what? How fast do these go? So small, apparently, from what I read, was that small wind turbines spin up to 100 miles per hour and large turbines spin up to 180 miles per hour. So that's definitely, uh, didn't realize how fast it went. But yeah, so I thought those were cool. Also, something very interesting that I saw when I was looking up um, not topics, research. I read that the Biden administration's goal is to increase domestic offshore wind capacity to 30 gigawatts by 2030, which is basically a strong signal on the technology's importance to clean energy transition and meeting climate goals. Like I had mentioned earlier, we were talking about climate change. Um, so yeah, I think that's like a big step towards clean energy. And I definitely think offshore um, wind farms would be amazing and beneficial. Uh, um, honestly, like when I read that, I was like, I didn't realize that offshore wind farms were a thing, but they are. So I definitely think that that's probably a really good thing because I'm sure there's a lot of wind by um, the water. So, and then my final comments. So honestly, I had a lot of fun looking into this project and topic. It really brought a lot of information. Like I didn't realize how much of an impact wind power really has, and I didn't realize how much really went into it. So I just want to say thank you for this opportunity and have researching this topic, and that's it. Thank you.